Welcome back, and today we're going to do more linear transformations. So we have an f of x right here in yellow, and we're going to translate this to different places. The first one we're going to do is f of x plus 2. The first thing we do is we take a look at the difference between the original f of x and what we have down here. And we're going to see that the x plus 2 on the inside has a plus 2. From our handy chart that we have from class, we're since whenever we add a positive value on the inside of the x value, we shift our function to the left by that amount. In this case, where since we're adding 2, we're going to be shifting our function 2 to the left. So let's do that real quickly. We're going to find our reference point, which I have highlighted right here. We have -3, 2. We're going to move this 2 to the right, which means that's going to be -5, 2. We have a -5 right here, and our point is going to move to here. Next one is -2, 2. What we're going to do the same thing. We translate it to the left by 2, and its new location is going to be -4, 2. Same thing with -1, 2. That's going to be -3, 2. Next one we have 1, 0. No, yes, 1, 0. We're going to translate that to the left by 2, which means that's going to be -1, 2, -1, 0. We have our next one is 2, -2 right here. We're going to translate it to the right by 2, to the left by 2, which means that's going to be 0, -2. And I am not making those dots. And finally, our last value is 3, 1. We translate it to the left by 2, which means we subtract the x value by 2, which puts us at 1, 1. So now we finish it off by drawing the remaining of the function. We have a curve that goes up. Seems like it reaches its height at around a third of the way. It comes back down, hitting the minimum at 2/3 of the way. We're going to try and mimic that real quickly. It goes up, then down, and hits our next point. Afterwards, it's horizontal. After that, it's constant. And then it concaves down to the x-axis, concaves up as it hits the y-axis, and concave down at the end. So there, and so this right here, the one we highlighted, we just drew, that's our new function. Although I could have done this much better on paper instead of. So let's take a look at our next one. Our next one is f of x plus 2, and this time our 2 is on the outside instead of inside. Let's use a sort of dark green here, or maybe I can get some aquamarine going. Here we go. F of x plus 2. Our 2 is on the outside. From our handy chart we have, whenever we add a positive value to our function, we shift our function up by k units. In this case, by 2. So our translation is going to be a vertical translation by 2 units. Let's go back to our point. Let's go back to our reference point. We have -3, 2, which means that's going to be -3, 4. -2, 2. We add 2 to the y value, which gives us -2, 4. we add our we add 2 to our y value here as well. This is negative 1 comma 2, which means that's going to be negative 1 comma 4. It goes through the y-axis, hits the x-axis at 1 comma 0, which means that's going to be 1 comma 2. Again, we have 2 comma negative 2. We add 2 to our y value, which gives us 2 comma 0. And our last one, 3 comma 1, we move it up 2. That puts us at 3 comma 3. Same thing as before. We're just going to connect the dots from here on. Going up and down, hitting the constant function, concaving down to what was the concaving down, passing through the y-axis, meeting at the x-axis, and eventually concaving down towards our last point. So our new function looks something like this. Let's remove that point right there. And as you can see, our function is being shifted by 2 in each and every single point. Right here, and right here, and right here as well. So let's go on to the next one. We have f of x minus 3, the 3 being inside. So same idea. We're going to take a look at the inside. Since it's x minus 3 this time, we're going to be shifting our function. Oh, not this one. We're going to be shifting our function to the left or to the right instead. Whenever we subtract the x value, whenever we subtract on the inside, we shift it to the right. So let's do that real quickly. We're going to take our reference points again, and we're going to move all those points over to the right by 3. So we have negative 3 comma 2. We shift it to the left by 3, which means that's going to be negative 1 comma 2. Negative 2 comma 2. That we shifted to the right. That means our point is going to be here. Negative 1 comma 2. That's going to be 1 comma 2 instead. Our 1 comma 0 is going to be shifted 3 to the right, which means that's going to be 4 comma 0. Or yes, 4 comma 0. Our next one is 2 comma negative 2, which means that's going to be 5 comma negative 2 instead. Right here. And eventually at the end we have 3 comma 1, which means shifting it 3 to the right would give us 6 comma 1. Let's extend our our line real quickly. Right around here should be good. So that's 5, and that's 6 right there. And so like usual, we're just going to fill in the middle between between these 2 points right here. We have a concave up to a third up to the top, then come all the way down, hitting the y-axis. After that, it's all constant. Let's make this a little bit thicker so we can see better. Up, then down, then straight. Then it concaves all the way down. Afterwards, let's double check down. Let's double check real quickly from this point to this point to this point. It should be a distance of 1, 2, 3, and we have the same thing right here. 1, 2, 3. Yep. Afterwards, after hitting the x-axis, concaves up and down towards the last point. So that is So this right here, let's fix that real quickly, is f of x minus 3, the 3 being inside. Let's take a look at our last one, f of x plus 2 minus 3. So we can see right here, there's two translations going on right here. One of them being the plus 2, which means we're going to be moving the function to the left by 2. And the other one being minus 3, which means if we go back to our chart, whenever we subtract a positive value, we move our function down by 3, or by k units. In this case, we're shifting it down by 3. So let's do that. So over 2 to the left and down 3. Let's put the down 3 right here because I think we need the space over here. Let's start with our reference point. Pop, but these we're going to translate this point, the first one, the one in the furthest to the end, over by 2, which means we're going to need to draw more number lines. Here we go. And let's put this as -6, or wait, 3, 4, 5, excuse me. That's -5 right there. Going to move it over by 2, 1, 2, -5, up to -5 comma 2, and we're going to move our function down by 3. So 1, 2, and 3, and so our new function is going to be all the way down at -1. Ooh, let's erase that real quickly to make room for our point. There we go. So our next value is -2 comma 2. We move 2 over. That puts us at -4 and down 3. And that's going to be -1. So our new point is -4 comma -1. Our last value is -1 comma 2. 2 to the right, 2 to the left would make this -3 comma 2. And we're going to move 3 down. So in this case, we have this point right here, -3 comma -1. So let's take a look at the other ones as well. We have 1 comma 0 right here. We move 2 to the right, 1, 2. Excuse me, we move 2 to the left. I am getting my left and rights confused today. We're going to move 2 to the left, and we're going to go 3 down. -1, -2, -3. There we go. Let's erase these extraneous dots here. Our next one is 2 comma -2. We move 2 over. That puts us on the y-axis, and we're going to go down 3. 1, 2, 3. And that point is 0 comma -5. Let's extend our number line a little bit more. There we go. We have a point down here, and eventually we have 3 comma 1. So over 2, 1, 2, and down 3, 1, 2, 3. And there's my point. Let's check our work really quickly. We have -3 comma 2. We move 2 over and down 3. Same thing with the other ones. We have 1 comma 0. We move 2 over and 3 down. 1, 2, 3. That puts us at -1, -3. I let's see, 1, 2, 3, yes. That's why this doesn't make sense. It should be right here instead. So let's connect all the dots again. Removing extraneous points, and let's connect all the dots. We have a maximum, then dip down to a local minimum. We have a horizontal, a constant function, followed by a concave up, no, concave down, then a concave up, and then eventually we hit all the way to the end right here. Not the most elegant graph ever, but it'll work for now. So our final answer is this curve right here. And you can see from before, let's use a different color this time. Compared to the original graph, we shifted 2 over. Let's use a different pen. We shifted 2 over and 3 down. Yeah, oh, let's do that a little bit better. 2 over, and afterwards 3 down. Same thing with the other ones as well. 2 over, 3 down, 2 over, 3 down. There's no dilation here because our function is not being multiplied by any factors, any values. And we're going to do some dilation soon. So onto some dilations. So here we have g of x, which is our graph in yellow, and we're going to find these 3 transformations. Let's start with 2 times g of x. I'm going to do this in a nice dark magenta in pen. There we go. So like before, we're going to take a look at the difference between the parent function and our new function right here. And we see that there's this 2 on the outside. If we take a look at our chart, whenever we multiply a function with a constant on the outside, we either stretch it or shrink it vertically. So in this case, since the 2 on the outside is bigger than 1, we're going to stretch it vertically. So our ending function is going to look something like this, where all the ends are getting closer and closer towards the y-axis. So let's do that really quickly. We're going to find our reference points as per usual, and we're going to just multiply our y values by 2. We have -2, comma 0. We have 1 comma, no, we have 0 comma 1, and we have 1 comma 0. And it seems like we could use this point here as well, this -1 comma 2. I think that's going to come in handy. So let's do that. Let's do that. Since -2 comma 0 has a y value of 0, 0 times 2, that's still going to be 0. So our ending point is still going to be right at the start. Same thing with the other point. 1 comma 0 has a y value of 0, which means 2 times 0 is 0, which puts us at the starting point again. Let's write that out as for practice. So we have these reference points right here, -2 comma 0. We have a 1 comma 0, 1 comma -1 comma 2. We have 0 comma 1, and the last one being 1 comma 0. So After transformation, this is -2, comma 0. Remember, we are only multiplying the y value by a factor of 2. So, and we mentioned before that 1 comma 0 is going to transform into same thing 1 comma 0. Let's take a look at these two other points right here. So for sure we know that the x values are going to stay the same because that's the only one we're changing. Let's take a look at the y value. 2 times 2, that's just 4. And 0 comma 1 is going to become 0 comma 2. Let's plop all these four points down. So we have -2 comma 0, we have 1 comma 0, we have, instead of 0 comma 1, we're going to have 0 comma 2. So this point right here, erase that. And instead of having -1 comma 2, we're going to have -1 comma 4 over 1 up 4. So at this point, erase that. And so we're just going to connect the dots as best as we can. Seems like this is sort of the initial function has this sort of parabolic shape. Let's try and mimic that. -2 seems like it goes all the way to the top, comes down to the y-axis, and where it breaks off and does its own thing on the right side. We have some sort of semicircle here, or a quarter of a half of a semicircle. Let's mimic that by drawing a semi-oval in. And there we go. That's our transformation. Let's take away g of x so we could see. And take out all these extraneous dots. So as we can see, our function is being more or less, well, that's exactly what's happening actually. Our function is being stretched up in the y direction. Think of it like you're on one end right here, and you're pulling the function up towards you. That's what's going on right here. So let's take a look at the next one, g of x over 2. So this time the x value is the one that's being manipulated. So x over 2 is the same thing as saying 1/2 times x. So we are scaling this. We're scaling our function by a factor of 1/2, but we don't really know if it's horizontally or vertically. Let's take a look at our chart. So whenever we have a function, a constant on the inside multiplying x, we are either stretching it horizontally or shrinking it horizontally. In this case, since our value is 1/2, we have a shrinkage because 1/2 lies between 0 and 1. No, excuse me, a stretch because 1/2 lies between 0 and 1. It's going to stretch out and pull it towards the end of our number line. So it's going to stretch by a factor of 2, or it's going to stretch. So let's take a look. Let's make our chart again, and we're just going to do this calculation. So we have our usual reference points. Let's use another color this time. We're going to rotate over to green again. Oh, let's do purple. Let's give me a dark or lighter purple color. Yeah, that's good. So we have 4 points of reference: -2, -2, comma 0, 1, comma 0, 0, comma 1, and -1, comma 2. let's write that down real quick. -2, comma 0, -1, comma 2, 2, 0, comma 1, and 1, comma 0. So all these are going to be transformed. So let's start with -2, comma 0. So if for -2, comma 0, it's going to be stretched by a factor of 2. It's going to be pulled at a factor of 2. So our x value is going to be doubled. So we have -2, comma 0, which means this is -4, comma 0. So right around here. Our next one is -1, comma 2. We double it, we get -2, comma 2, 0, comma 1. That's still going to be 0, comma 1. 1, comma 0 is going to become 2, comma 0. So let's go ahead and plot those points down. We have -4, comma 0, -2, comma 2, 0, comma 1, same spot, and 2, comma 0. Let's erase the points that we don't need, like this one, and this one. So whenever we have a a fraction being multiplied to our x value, we take the reciprocal of it. So in this case, we take the reciprocal, which is 2, and that's going to be our factor of scaling. That's how I got all these numbers right here, or these numbers along the other side of the table. So let's connect them. We have we have a curve. We have a sort of a hill up here, meeting at our y axis, and then it curves all the way down, and our end result is something like that. As you can see before, just like I said before, the 1/2, the factor of 1, the factor of 2, or this 1/2 constant, is stretching our graph towards our both ends of the paper. Let's go on to the next one, or the last one. So now we have a dilation and a translation on top of it. So it's 3g, or let's change that 7 to be a smaller number. Let's because if I were to go up by 7, I don't think I have enough graph paper to handle it. Let's change that to a 1. Yeah, let's change that to a 1, and we're going to use a different color as well. I'm going to use, so it's going to be 3g, 3 times g of x minus 4 plus 1 instead of 7. I think that would do much better. So let's take a look at our graph right here. We have, let's use, we're going to use sort of a, let's go with orange this time. We have our 4 reference points, -2, comma 0, 1, comma 0, 0, comma 1, and -1, comma 2, these 4 points. And we're going to write them down real quickly. -2, -2, comma 0, -1, comma 2, 0, comma 1, and 1, comma 0. So first things first, we can do this 2 ways. We can first do the translation first and then do the dilation, or we can do it the other way, doing the dilation first, doing the dilation first before doing the translation. So let's do this both ways. The first, I'm gonna do the dilation first before doing the translation to show you guys that they're the same graph. So first we have a 3 in the front, which means we're going to be multiplying all of our y value by 3. Let's do that dilation. Negative 2 comma 0 is still going to be negative 2 comma 0. Remember, we are multiplying our y values. Negative 1 comma 2, we're going to multiply our 2 by 3, which gives us negative 1 comma 6. 0 comma 1, that's going to be 0 comma 3. 1 comma 0 would give us 1 comma 0. Like just like before, we're multiplying our y value by 3. 0 times 3 is 0. Let's graph that first before we translate. So we have negative 2 comma 0 right here. Right there, same spot. 1 comma 0 is still in the same spot. Negative 1 comma 6 looks like I'm going to have to extend this. Let's use a different pen. That's going to be all the way up around 2, 3, 4, 5. Let's say right here. Here is 6. So we have our maximum up here. 0 comma 3, that's going to be right here. And 1 comma 0 is still going to sit in the same spot. We draw that in, hitting its maximum, comes down to the y-axis before finally meeting with the x-axis on the bottom. Now, let's take a look at our translation. We know that it's a translation because we're adding and subtracting values on the inside and the outside of the function. So this negative 4 tells me that we're going to shift our function to the right by 4. Similarly, that plus 1 tells me that I'm going to be moving that function up by 1. So we have our previous reference point, and we're going to just do just that. Our negative 2 comma 0 is going to translate up over 4 in the x direction, which gives us 2, and up 1 in the y direction, that gives us 2 comma 1. Similarly, negative 1 comma 6, move it to the left by 4, that's going to be 3. Move it to the right by 4 is going to be 3 comma 6, adding 1, which makes 7 for the y direction. We're shifting our function to the right, which means we're going to add 4 to our x value. 0 plus 4 is 4. Afterwards, we're going to shift our function up by 1. So we have to add 1 to our y value, which is 4 comma 4. And for our last one, we're going to shift our function to the right by 4. That gives us 5. We're going to shift it up by 1. That gives us 1. So our final function has these 4 reference points that we can use. So let's graph that. 2 comma 1 right here. 3 comma 7 all the way up here. 4 comma 4 right here, and 5, let's pretend that 5 is right around here. 5 comma 1 right down here. And we're just going to copy what we did before. The curve goes all the way up to its maximum before coming back down, making a making 3/4 of a parabola before it ends. And then afterwards, we're going to make our semi-oval. And there we go. And that is g 3 times g of x minus 4 plus 1. If you find this video helpful, please like and subscribe. Please share this video. Thank you.